Hey guys, welcome back. This is Mr. Weinkauf with Embrace Tutoring and Educational Services, and today we're going to be focusing on the SAT Practice Test 8, Math Section 4, questions 21 through 30, and this will be the detailed answer video. For problems 21 and 22, I'm going to be referring to this narrative here as well as this graph, and I see here I have my X and I have my Y axis. They also provide me a line of best fit. It says between 1985 and 2003, data were collected every 3 years in the amount of plastic produced annually in the United States in billions of pounds. This I see here along my x-axis, millions of years is along my y-axis. And it says the equation of the line of best fit, y equals 3.39x plus 46.89. And I can already see that my 46.89, when my x is 0, this is going to be my initial amount. And the 3.39 is most likely going to be correlated to the rate in some way, or kind of the rate of increasing or slope. It says where X is the number of years since 1985 and Y is the amount of plastic produced annually in billions of pounds. So let's slide down and see what the question is asking. Which of the following is the best interpretation of the number 3.39 in the context of the problem? Well, if I had here in terms of Y equals 3.39x, plus my 46.89, I can see that this is in the same standard format as my y equals mx plus b. I can also see that the 46.89 is really going to refer to my initial amount, and the 3.39 is really going to refer to the rate. And that rate is going to be, it looks as though as I read the graph from left to right, is going to be increasing. So the 3.39 is going to refer to my rate, and the rate is going to be increasing. So let's take a peek at my answer choices to see which one of those reflect that answer. And slide down. I'm going to get rid of this information. Which of the following is the best interpretation of 3.39? The amount of plastic in billions of pounds produced in the United States during year 1985. Well, that's not correct. It's a little bit too vague. The number of years it took the United States to produce 1 million pounds. No. The average annual plastic. Well, now this is a little bit better in terms of the terminology because we're talking about the y over the x, right? Plastic per years. So the average annual plastic production in billions of pounds in the United States but they never really mention per year here. And here it says the average annual increase in billions of pounds of plastic produced per year. So there's my rate, and I know that I'm kind of connecting that rate given the fact that I'm combined with my x because it's 3.39x. And it also says that it's increasing, which is correct, because my slope here is going up as I read my line of best fit left to right. So D is going to be your best answer for question 21. Question 22 states, which of the following is closest to the percent increase in billions of pounds of plastic produced in the United States from 2000 to 2003? Let's slide back to get a better idea of the graph here. And it says within the graph that X is the number of years since 1985, which is very important. So since 1985, and I know that the question just asked me about the year 2000, and 2000 minus 1985 equals 15. So I'm talking about 15 years, and even now working up to, I believe it also stated 2003. So we're talking about year 15 and year to year 18. So I'm going to look here at my graph, number of years since 1985. I'm really referring to this year here, which is 15, and then working up to 18, right? So year 15 is really 2000, and this symbol here, or this 18, is really representing 2003, right? 2000, 2001, 2002, 2003. So I'm going to slide up. This is my value for 2000. And this is my value for 2003. Now the question is really asking what is the percent increase of this point going to that point from the 2000 to the 2003. And in year 15 or in year 2000, 15 years after 1985, we see that we have 100, right? 100 is going to be our value, or 100 in billions of pounds of plastic. In 2003, we see that we are going to be moving on and going to, I would say it's probably approximately 110. Here I have 100, here I have 120. It's kind of somewhere in the middle, kind of estimating. So how does, in year 2000, how do we end up going from 2000, where we have 100 billions of pounds of plastic, to year 2003, where we have 110 billion? Well, this is a 10% increase, right? Going from 100 to 110 is going to be 10%, or better yet, if I said 100, right, and then times 0.1, this is going to figure out what is my 10%. This is 10, then I were to add this plus 10, and that's how I end up going from 100 to 110. So it's going to be an estimated of 10% increase. Let's go back to the other problem. Let's scroll down, that way you can see it. So let's clear this, that way you guys can have that. And for problem 22 then, A should be my best possible answer because it will be a 10% increase going from my 100 to 110. Problem 23, I see that I have an equation here, m equals 1800 multiplied by 1.02 to t, or the t power. 1800 is going to be my initial amount, or my starting amount for what I have. The 1.02 looks like as though it is going to be a rate increase, right? That 0.2, or that, right, the 1 is to account for 100% of the original. The 0.2 looks as though it's going to be an increase. And the m corresponds to the number of members, m, of a gym t years after the gym opens. So t is referring to time or years. Of the following, which equation models the number of members of the gym q quarters years after the gym opens? Well, it says q quarter years after the gym opens, and I need to know that there are essentially 4 quarters in 1 year, right? A quarter is referred to as 1/4, and so I would need to be aware that my time is going to be affected by 1/4, and my initial would still stay the same, my rate increase would still stay the same. So I would need to have a 1/4 in my expression somewhere, and A is the only one that represents that. So q quarters, meaning that each 3 months equals 1 quarters, and I'll have 4 quarters in 1 year, or 12 months total. So A will be my best answer for question 23. For question 24, for the final of a TV show, viewers could use either social media or a text message to vote for their favorite 2 contestants. The contestant receiving more than 50% of the vote won. An estimated 10% of the viewers voted, and 30% of the votes were cast on social media. Contestant 2 earned 70% of the votes casted using social media and 40% of the votes cast using a text message. So he seems to be the favorite, although only 10% of the votes were actually, only 10% of the viewers voted, and he needed to have at least 50% of the votes overall to win. Based on this information, which of the following is an accurate conclusion? Well, there's not a lot of information here, and it all kind of seems pretty vague. So let's see what we can decipher for what makes the most sense given the information that we have. If all viewers had voted, contestant 2 would have won. Well, we don't exactly know that because only 10% of the viewers have voted, and there's not enough information yet to cast that in terms of like a plausible prediction. Viewers voting by social media were likely to be younger than viewers voted. Age is never even mentioned, so it's completely out of scope for what the question is asking. If all viewers who voted had voted by social media instead of by text message, contestant 2 would have won. Well, it says if all viewers who had voted by social media instead of text message. Well, he was already the heavy favorite in terms of social media, and 40% of the cast using text. You don't exactly know. I mean, it could be C, perhaps not. It's not kind of really direct enough in terms of what they're giving you. Viewers voting by social media were more likely to prefer contestant 2 than viewers voting by text message. Well, this is the only one that's clear. This is the only one that's clear based off the information that we're given. And that the viewers voting by social media chose the contestant 2 70% of the time. And that's evident according to the information presented. So 24 will most likely be D. Question 25, population of Greenleaf, Idaho, year 2000-2010. Here I have a 10-year difference. Here I have population 862 to 846. I see that I have a difference of minus 16, right? 862 minus 846 gives me minus 16. The table above shows the population of Greenleaf, Idaho for years 2000 and 2010. If the relationship between the population and year is linear, meaning it will stay at the same rate, which of the following functions P models the population of Greenleaf T years after 2000? So T years after 2000 will be decreasing, so it's not going to be C. I'm immediately cutting this one out. and it could very well be A, B, or D, given the decreasing thus far. So let's figure out why is it here. This is my initial amount, and what are the true differences? Well, if I were to select kind of t, well, this is my minus 2,000 for my t, not quite going to be the case. I want to need to find something in terms of the slope being the linear. So I could set this up in terms of a standard kind of y2 minus y1 over x2 minus x1. And if I use, let's say that this is going to be my 2's and x's, well, let's say that I have 846 minus 862, right? 862 is my initial, so this will be my y1. This is going to be my new value, so this is my 846. This here will give me the negative 16, which is how I know that it's decreasing overall. And this is going to be over my 2010 minus my 2000, and this is 10, right? So I have negative 16 over 10, which gives me negative 1.6. So my slope should be right around negative 1.6, and A is then going to be my best answer. I have my initial amount, and I have my slope. And once again, this slope is representative of both. So this is actually going to be a rate. This is a negative 1.6 population decrease per year, which is why I can connect this to time, because then when these are multiplied together, they will simply cancel, and then I will stay within units of population, which is what the P model here is going to represent in terms of total population. Question 26 states, to determine the mean number, meaning the average number of children per household in a community, Tabitha surveyed 20 families at a playground. For the 20 family survey, the mean number of children per household was 2.4. Which of the following statements must be true? Well, before I even read these statements and get kind of lost in the answer choices, let's think about what she had done and conducted her survey. To determine the mean number of children per household. So she's attempting to try and figure out what is the average number of children per household, right? Average number of children per household, and yet she's going to a playground where she knows children will be. That seems a little biased or a little flawed, right? The fact that she's going to a playground means that there's bias. It probably would have been better for her to actually just, I would say, visit door to door would be a better circumstance, visit door to door, because then what if there's instances where families who live in this community actually don't have any children, or perhaps one, or perhaps, right, more than one. Perhaps they're all grown and they've had children that have actually moved out and they no longer go to the playgrounds together, right? Whatever the circumstance may be, her going to the playground is creating a lot of bias. Also, 20 families really isn't that many in terms of a large sample size. And for all intents and purposes, she would want a large sample size, and she would want to go to a number of different houses within the community, and she would want to be able to, rather than kind of this one particular place. So let's take a quick look at the answer choices. The mean number of children per household in the community is 2.4. That may not be true because she only kind of evaluated 20 families. A determination about the mean number of children per household in the community should not be made because the sample size is too small. Perhaps, right? I'm actually kind of leaning towards this one right now. The sampling method is flawed and may produce a biased estimate of the mean number of children per household in the community. Well, this is definitely true. C is definitely true and speaks with a lot more conviction because of the fact that she's going to a playground in order to evaluate how many children per household there are. The sampling method is not flawed. Well, that's not true. It is flawed. I would say C is the better answer than B because having 20 families is relative in terms of what is a large sample size and not. C is definitely true, where the sampling method is flawed given the fact that she's going to a playground. So 26 is going to be C. Okay, 27. In the xy plane, the point PR lies on the line with the equation y equals x plus b, where b is a constant. The point with coordinates 2p, 5r lies on the line with the equation 2x plus b. All right, so I see here b is a constant. Both of these are related, and I have various points that go into each. And remember here that this format is the XY format in terms of P and R. So I can actually label this y equals x plus b. I can make this equation, right, given the P and the R, I can just simply plug in. So here I have R equals, let's say, P plus B. And this is, we'll even just call this equation 1. And the reason I'm trying to label the R and the P and begin to incorporate, So as I see here, if P is not equal to 0, what is the value of RP? So RP overall is what I'm attempting to find. I know that B is my constant, which is how I'm going to relate both of these equations together, and I can plug in for points in terms of my P's and my R's, or my 2 P's and my 5 R's. So here's my equation 1, R equals P plus B, given my equation here, and then I know B is a constant. Now I'm going to do my equation 2, which is y equals 2x plus b, and I'm now going to plug in these values for how they would correspond to the line. So 5r equals y, right, given once again the format, and my 2p I'm going to plug in for my x. So I'm going to plug in 2p here plus b. B is a constant, so b should be the same for both, meaning that I can solve these equations and set them both equal to b, right? And if I have 5r equals 4p plus b, then I can manipulate this equation to say that 5r minus 4p equals b. Well, why do you care about that? Because now if I have 5r minus 4p equals b, I can do the same for this. I can say that r minus p equals b, and I can set this equal on this side. So if b is the constant, then r minus p is going to equal 5r minus 4p. Now I have my expression of 5r minus 4p equals r minus p. I'm going to, let's say I want to subtract r from both sides, subtract r over here, and now I have 4r minus 4p equals my minus p. I'm now going to, let's say I want to add 4p to both sides, so add 4p, and just to get them on opposite sides at the time being. And then now I have 4r equals 3p. Well, what I want to solve for is the fact that I'm trying to solve for r over p. So I want to try and get r over p, meaning I'm going to now divide both of these sides by p, right? Because I want to get r over p, cross those out. And now I have 4r over p equals 3. Well, and now I have 4r over p equals 3. And now I want to divide both sides by 4 so that way I can cancel out. And what I end up getting is that r over p is going to equal 3/4. So if I go back to my possible answer choices, and I should see 3/4, and it is. So 27 will be B. 28 states, the 22 students in health class conducted an experiment in which they each recorded their pulse rates in beats per minute before and after completing a light exercise routine. The dot plots below display the results. I see initially here that there's like a large cluster of results, and it's not very diverse. Whereas here I see that there are a lot of various results, and there's not really a lot of clusters. So here there's a cluster, meaning that many of the results are revolving around the same area, and then here there's a lot of kind of variation within the results. So we'll call that variation. And it says, let S1 and R1 be the standard deviation and range respectively. So very briefly, standard deviation is a calculation where you are attempting to figure out what is the actual variation. So standard deviation is a calculation, let's say, used to quantify, right? That's a good wording for it. Standard deviation is a calculation used to quantify the amount of variation within a data set, And now there are more precise calculations I can give you, but realistically, you just need to understand what it is conceptually. And conceptually, this one has a lot of standard deviation. So this one's standard deviation is a lot, whereas here, this one's standard deviation is not so much because it's clustered. And then it says R1 is the range, respectively. Well, range is just simply the, let's say, the largest minus the smallest, right? Largest minus the smallest. And you can figure out the range by the two data points. Now let's attempt to clean this up a bit so you can see it a little bit better. It says, so let S2 and R2 be the standard deviation and range, respectively, of the data after exercise. Which of the following is true? Well, 1 they do not have the same standard deviation. I see kind of that it does say that they do not have the same standard deviation. So anything where it says the same standard deviation is not going to be the case. And that's because here it's very clustered and here it is very varied. Now, regarding the range, I'm going to take the 88, I'm going to subtract it by the 56. So 88 minus 56, and this is referring to range 1, being the data set of beats before exercise. And this will give me, so 88 minus 56 is 32. And now if I do my range 2, I'm going to have 112 minus 80. I see. And it is also 32. So my ranges are equal, but my standard deviations are not. And S2 has a greater standard deviation than S1. So choice D will be my best example. Now I wrote it in this here, but this is also saying that S1 is not equal to S2, right? They do not have the same standard deviation, regardless of whoever has more or less, right? These are not equal, and my R1 and my R2 are equal given my ranges. So D will be my best answer choice for question 28. Question 29, a photocopy machine is initially loaded with 5,000 sheets of paper. The machine starts a large job and copies at a constant rate. After 20 minutes, it has used 30% of the paper. Which of the following equations models the number of sheets of paper P remaining M minutes? Okay, so M minutes is after the machine started. Well, 5,000 is symbolizing my initial. P is representing the number of sheets of paper that I have remaining. And here it looks as though I'm subtracting, right? Because of the fact that it's asking me how many sheets of paper will I have remaining. If I start with something and if I'm using 30% of that after 20 minutes, well, I'm either going to be between A or B rather than this is 30% remaining, but this is incorrect in terms of the way that's symbolized, and this is also incorrect. So I'm going to be, it says, what is P remaining in the machine P M minutes after the machine started printing? Now the way to determine this is that if I have 5,000 sheets and I'm using 30% of those sheets, 20 minutes, it's 5,000 times 0.3. This is going to be, now if I break this down, kind of a quick estimate without, you're more than welcome to use your calculator to make it easier, but if I break 5,000 down into 10 parts, which then becomes, right, my 500, then I just simply multiply 500 times 3, right, be my 30%, and there's where I'm getting my 1,500 from. And then, so this is my 1,500, but this is 1,500, and I need to calculate the number of sheets per minute, right? This is 1,500 sheets per 20 minutes, and I want to know, well, how many sheets will I have per, let's say, 1 minute? And very quickly, mathematically, I can start crossing out some zeros here, and I have 150 divided by 2, which is going to be 75 sheets per 1 minute, right? 75 sheets per M per 1 minute. And I like that, because this tells me that this B is going to be my best answer to question 29, given the fact that it's connected to a rate, and P is the amount of sheets that I have remaining. 5,000 is my initial, minus 75 sheets per minute of what I'm taking off. So B will be my best answer for question 29. Question 30 states, the complete graph of the function f and a table of values for the function g are shown above. The maximum value of f is k, meaning where's the peak, and it looks as though this is the peak, right? The maximum value of f is k. What is the value of g of k? Well, once again, I see from my graph that the highest point on the graph, so the highest point here, and I can see from my graph that this is where x equals 4 and my y equals 3. And here that means that if f is k, that means that k equals 3, right? Because my f of x is really representative of my y, right? F of x equals y. So when x equals 4, they're saying that y equals 3. And then the question says, the maximum value of f is k. What is the value of g of k? So what is the value when you are plugging 3. Really what you're going to do with this information, given the x and the g of x, is that if you're able to plug this in, if you know that when, let's say, x equals the 3, or that when the k, right, is equal to the 3, then if I were to plug this into my g of x equation, so if I have g of k equals g of 3, meaning that x is equal to 3, so I'm going to go down and I'm going to look here. When x is equal to 3, then my g of k, or my g of x, is going to equal to 6. So 6 will be my answer for question 3.